We are back with another video about stoichiometry, and in this video we're going to talk about limiting reactants. So the limiting reactant is the reactant that is consumed completely in a chemical reaction, and we call it the limiting reactant because it limits the amount of product that's formed in that reaction. Now, if the reactant isn't a limiting reactant, it's an excess reactant, meaning that there is some left over. So the excess reactant is the reactant that's left over after the limiting reactant is consumed. For the reactions that we'll look at, we have two reactants, reactant A and reactant B. And so in many cases, one of those reactants will be limiting and the other reactant will be excess. Now we can run into a situation where you get the perfect amount of reactant A to react with all of reactant B, and so you get no leftovers. We call that a stoichiometric mixture. I don't show one of those examples in this video, but it's likely that we'll come across one through all the practice problems and stuff we do. So in that case, no leftovers, each of the reactants is consumed completely, and it doesn't really change the way we handle our calculations. So let's get into our first example here. So how many moles of NH3 are made when 6 moles of N2 reacts with 6 moles of H2? Well, before we do any math here, let's look at this problem. So you'll notice that in this case, we're given amounts for each of the reactants, right? So we have 6 moles of N2 and 6 moles of H2. When you're prescribed amounts of each reactant, you need to be thinking in terms of limiting reactants, right? It's likely that one of these is going to run out first, and it's going to affect the amount of product that we can make. For calculations like this, there are actually two ways you can do it. So I'm going to break down each of those methods in this video. So method 1, we're going to compare the amounts of product formed from each amount of reactant that we're given. So I'm going to take my 6 moles of N2, and I'm going to calculate how many moles of NH3 I can make from those 6 moles. So you can see I'm using the mole ratio of NH3 to N2. So 6 moles of N2 can make 12 moles of NH3. I'm going to do another calculation where I do the same thing for 6 moles of H2. So 6 moles of H2 times my mole ratio, 2 NH3 over 3 H2, gives me 4 moles of NH3. Now we compare the amount of product that can be made here, and the answer to our question, how many moles of NH3 can be made, is going to be the smaller amount, right? Because the limiting reactant limits the amount of product that can be formed. So I'm actually going to use the smaller amount here, which is 4 moles of NH3, as my answer, and that means that H2 is the limiting reactant. In method 2, rather than comparing product amounts, we're going to compare reactant amounts. So same setup here. How many moles of NH3 are made when 6 moles of N2 reacts with 6 moles of H2? And this time, I'm going to compare how much of one reactant I need to what I'm given. So I'm going to pick a reactant. In this case, I'm going to pick 6 moles of N2. And I'm going to figure out how many moles of H2 I need to react completely with that 6 moles of N2. So I use my ratio 3/1, and I find that I need 18 moles of H2 to react with all 6 moles of that N2. So in order to figure out which reactant is limiting, I'm going to compare the amount of H2 that I need, which is 18 moles, that's what we just calculated, to the amount of H2 that was given, which is 6 moles in the problem. So the fact that I need more moles of H2 than I'm given leads me to conclude that H2 is the limiting reactant, right? We need more than we have. So H2 is limiting. Once I know that H2 is my limiting reactant, now I can calculate how many moles of NH3 are going to be made. So I take the amount of H2 that I have, 6 moles, that's what's given in the problem. and I convert that into NH3 using the 2/3 ratio. So this is the calculation that we did in method 1. And once again, I find that we can make 4 moles of NH3 in this reaction. In our second example, we're going to use the same reaction, but notice this time we start with 20 grams of N2 and 5 grams of H2. So the amounts that were given for each reactant are in grams. So that means that we need to convert from 20 grams of N2 into moles of N2 and 5 grams of H2 to moles of H2 before we can do any stoichiometry. Once again, we'll take a look at method 1 first, and we'll compare the amount of NH3 that can form from these reactants. So 20 grams of N2 divided by its molar mass will give me moles of N2. Remember, I need to be in terms of moles before I can use my mole ratio. So 0.71 moles of N2 times the mole ratio, 2/1. I can expect to make 1.42 moles of NH3 from my 20 grams of N2. We'll do the same calculation for our 5 grams of H2. We'll take 5 grams of H2 divided by the molar mass, 2.02. So I have 2.47 moles of H2, and we'll convert that into moles of NH3 by multiplying by the 2/3 ratio. So in this case, I can expect to make 1.65 moles of NH3. As we compare these two amounts of product, we're going to take the smaller one, so 1.42 moles of NH3 is what we can expect to make, and that means that N2 is our limiting reactant in this case, because the limiting reactant will determine how much product can be made. And for this question, we're asked how many grams of NH3. So our last step here is a moles to grams conversion. We'll do 1.42 moles of NH3 times its molar mass, which is about 17. We'll get 24.3 grams of NH3 as our answer. And we'll round that to 2 sig figs, so 24 grams of NH3. All right, let's look at the same problem using method 2, and we'll compare the amount of reactant that we're given to the amount that we need. So I'm going to pick one of my reactants. I'll take the 20 grams of N2 in this case. And again, I want to convert it to moles so I can get it into a quantity that I can work with. So 20 grams of N2 divided by the molar mass gives me 0.71 moles of N2. Now what I want to do is figure out how many moles of H2 are needed to react with all of that N2. So I'm going to do the mole ratio, 3/1, and I calculate that I need 2.13 moles of H2 to react with all 0.71 moles of N2. Now let's compare that many moles of H2 that we need to what we were given. So we'll do our 5 grams of H2 converted to moles. So we're given 2.47 moles of H2. So to figure out our limiting reactant, we're going to compare what we were given to what we need. And in this case, we can see that we were given more moles of H2 than we need. So in that case, we can conclude we have enough H2, therefore N2 must be the limiting reactant. Once I know that N2 is my limiting reactant, I can use it to calculate how many moles of NH3 will form. So 0.71 moles of N2 times the ratio 2NH3 over 1N2 gives me 1.42 moles of NH3 made. And then lastly, I'll do a moles to grams conversion, so we get our final answer in grams. 1.42 moles of NH3 times the molar mass, 17 grams. And once again, we get 24 grams of NH3 made in this reaction.